The elements of the universal set U are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Consider two subsets of U. Set A contains the multiples of 2, set B contains the multiples of 3. So A contains 2, 4, 6, 8, 10 and B will contain 3, 6, 9. Now 6 is common to both A and B, so it will be placed here in this intersection part of A and B. 1, 5 and 7 will be outside. Determine the probability of A given B complement. So probability of A given B complement is a conditional probability, and according to its definition it is probability of A intersection B complement by probability of B complement. Now probability of A intersection B complement means, let's find the region. A is this region, B complement will be outside B. So in this region A intersection B means which is common to both. A intersection B complement will be this part, which is common to both A as well as B complement. So probability of A intersection B complement will be 4 elements out of the total 10 elements. So this is going to be 4 by 10 by probability of B complement. B complement contains these 4 plus 3 elements, so 7 by 10. So 10 and 10 will get cancelled. It's 4 by 7. In decimal form, 4 divided by 7 is 0.571, rounded off to 3 decimal places. Now next question is, two numbers are selected at random from U. Calculate the probability that only one is an element of A intersection B complement. So since we are selecting two elements and one should be an element of A intersection B complement, let's consider that the first one is an element of A intersection B complement. So then there are 4 elements out of the 10 elements. So first one is an element of A intersection B complement whose probability is 4 by 10. And now since we have selected one element, there are remaining 9 elements. And it should be selected from the other set which contains 6 elements. These 6 elements. So it is going to be 6 by 9 or vice versa. The first 10 elements we can choose one from this set which is not our A intersection B complement. So there are 6 elements which we can choose from out of 10. And from the remaining 9 elements we have to choose this from A intersection B complement. So there are 4 elements which we can choose. So 4 by 9. So this is going to be 24 by 90 plus 24 by 90, which is 48 by 90. In the simplest form, this is going to be which we can again reduce by 3. So this is going to be 15. This is 8, which in decimal form it's 0.53 recurring. The table below shows an example of a completed addition grid. 4 plus 3 is 7, 5 plus 3 is 8, 4 plus 10 is 14, 5 plus 10 is 15. Write down the values of APC in a simplified exact form. So here we have to find ABC. So first of all we know that log of A plus log B is equal to log AB. This is the first important rule of logarithm. So here to find A, we will take A plus log 6 should give us log 3. So A is nothing but log 3 minus log 6, which is equal to log of 3 by 6, because log A minus log B is log A by B. So log 3 by 6 is same as log half, or it is same as log 2 to the power minus 1, because half is 2 raised to minus 1, which is same as minus log 2, because log A raised to n is n log A. So minus 1 we can take outside. So value of A is minus log 2. Now to find B, we know that log 2 plus log 6 is B. Log 2 plus log 6. Now we know log A plus log B is log AB. So this is log 2 into 6, which is log 12. So B is log 12. Similarly, to find C, we know that log 2 plus log 16 is C. So C is log 2 plus log 16, which is same as log 2 into 16, which is log 32. So C is log 32. A skateboard ramp set is built using functions provided in the diagram below. So we have a skateboard ramp set here. So the first function, this part resembles ramp 1, which is built using the function f of x is equal to 4 raised to x. Then we have a platform whose equation is h of x is equal to 2. Then we have a ramp 2 whose equation is g of x is equal to 3 raised to 5 minus x. We have to determine the value of a. So A is the point which is formed at the intersection of ramp 1 and platform. So f of x is equal to h of x at A. That is 4 to the power A will be equal to 2. Taking log on both the sides, A log 4 is equal to log 2, or A is log 2 by log 4, which is equal to log 2 by log 2 raised to 2. Taking this 2 outside, A is log 2 by 2 log 2. Log 2 is getting cancelled. A is half. Now B part is to calculate the value of B. B is formed by the intersection of platform and ramp 2. Therefore 2 is equal to g of x at B. 2 is equal to 3 to the power 5 minus B, because g of x is 3 to the power 5 minus x. Now taking log on both the sides, log 2 is equal to 5 minus b into log 3, or 5 minus b is equal to log 2 by log 3, or b is 5 minus log 2 by log 3. Putting this in calculator and solving, we'll get b is equal to 4.369070. So b is approximately 4.37. Now C part is to determine the length of the platform. The length of the platform is nothing but b minus a. So already we know the value of b is 4.37 minus the value of a is 0.5. After subtracting, we'll get the length of the platform as 3.87. Below is a geometric sequence with first term u1 is equal to 4 and common ratio r. Write down the value of r. So now common ratio of a geometric sequence is obtained by finding the ratio of the second term to the first term or third term to the second term. So here we have 2 root 2 by 4, which is root 2 by 2 or 1 by root 2. So r is equal to 1 by root 2. Now second part, B part, is to find the value of n when un is equal to r. Now nth term of a geometric sequence un is equal to a r to the power n minus 1, where a is the first term of the geometric sequence and r is the common ratio of the geometric sequence. So this is equal to 4 into 1 by root 2 to the power n minus 1, which is equal to 1 by root 2, which is equal to r, which is given in the question. So we know that 1 by root 2 to the power n minus 1 is 1 by 4 will come to this side, 4 root 2. Now this is same as root 2 to the power negative of n minus 1, which is minus n plus 1, is equal to 1 by 4 root 2. Taking root 2 here and simplifying the left side, we'll get root 2 raised to the power minus n plus 2 is equal to 1 by 4. Writing the right side in terms of root 2, we know that 1 by 4 is root 2 to the power negative 4. Equating the exponents, we'll get minus n plus 2 is equal to minus 4, or minus n is minus 6. So n will be 6. Now C part of the question is to find the value of k, given that u21 is equal to 2 raised to k. Now u21 is the 21st term of this geometric sequence. u21 is equal to 4 into 1 by root 2 to the power 21 minus 1, which is equal to 4 into 1 by root 2 to the power 20. Now given that u21 is equal to 2 raised to k, so 2 raised to k is equal to 4 into 1 by root 2 to the power 20. So 2 raised to k is equal to 4 into 1 by 2 raised to 10, because 1 by root 2 to the power 20 is 1 by 2 to the power 10. Now this can be rewritten as 2 raised to 2 by 2 raised to 10. So 2 raised to k is equal to 2 to the power minus 8, or k will be negative 8. Now find the sum to infinity of this geometric sequence. So sum to infinity of any geometric sequence is given by the formula a by 1 minus r, where a is the first term and r is the common ratio. So substituting a and r, we'll get sum to infinity as 4 by 1 minus 1 by root 2, which is same as 4 root 2 by root 2 minus 1. Rationalizing this, we will get the answer as 8 plus 4 root 2. Rationalizing in the sense multiplying numerator and denominator by root 2 plus 1, we will get numerator as 4 root 2 into root 2 plus 1, and denominator as root 2 into root 2 as 2, and negative root 2 and positive root 2 will cancel. Minus 1 into plus 1 as minus 1. So denominator is 1. Numerator will multiply each and every term. So 4 root 2 into root 2 is 4 into 2, which is 8, and 4 root 2 into 1 is 4 root 2. Comparing, we'll get A as 8 and B as 4. A diagram is given here where C is the center of the sphere and R is the radius of the sphere. We have to show that the radius of the sphere R is equal to 2.80 centimeter, correct to 3 significant figures. So redrawing the triangle here, we know that this is the radius of the circle and this is also radius of the same circle. So since both are radii of the same circle, this is an isosceles triangle, and it's given that this is 150. So by angle sum property, we know that 180 minus 150, which is 30, will be divided by 2, and each of these angles will be 15 degrees. Then by using sine rule, we can find that r is equal to 2.8. That is, sine rule tells us that 5.4 divided by sine 50 is equal to r by sine 15. Solving this, we will get r as 2.79524. When rounded off to 3 significant figures, r will be equal to 2.80. Now for the B part, the whole sphere of ice is melted in the cone as shown in this diagram. We have to find the value of h. Since this sphere of ice is melted into the cone, volume of sphere and volume of cone will be same. Now we know that volume of sphere is 4 by 3 pi r cube, which is 4 by 3 pi into 2.80 the whole cube, and that is 91.9523. Volume of cone is given by the formula 1 by 3 pi capital R square h, because radius is capital R and height is h, and that is equal to 91.9523. This is also 91.9523. Now from this right angle triangle, we know that tan 15, because when you split this, 30 will be split into two parts. Tan 15 will be opposite by adjacent, which is r by h. So capital R will be h into tan 15. Substituting capital R into the first equation, that is substituting capital R is equal to h into tan 15 into the first equation, we'll get that 1 by 3 pi h tan 15 the whole square into h is 91.9523, or 1 by 3 pi tan 15 square into h cube, because this h square will get multiplied with this h, it will become h cube, that is equal to the volume. H cube will be 91.9523 divided by this 1 by 3 pi tan 15 the whole square. Now when you put this in the calculator, 1 by 3 pi tan 15 the whole square is 0.0751. So h cube is 91.9523 divided by 0.0751. H cube is 1223.003379. So h will be cube root of this, which is 10.69405842, which is approximately 10.7 centimeters. So h is equal to 10.7 centimeters. Body temperature changes during the day. The graph below shows a cosine curve modeling the body temperature for in-grid. B is the temperature in degrees Celsius. T is the time in hours after midnight. So the graph is given here. Ingrid knows it is best to sleep for 8 to 10 hours when her body temperature is 36.5 degrees Celsius or below. Suggest a sleeping schedule for Ingrid. So we have to consider this statement here. She has to sleep for 8 to 10 hours and her body temperature is less than 36.5 degrees Celsius because that is the best time for her to sleep. So from the graph, it is clear that from 12 a.m. to 6 a.m. because it's 6 hours after midnight, her body temperature is below 36.5. Also, starting from 18 hours after midnight, which is 6 p.m. to midnight, which is 12 a.m., her body temperature is again below 36.5 degrees Celsius. So, we can suggest a suitable time from this part, that is maybe from 8 p.m. to 5 a.m. we can consider as a suitable schedule for Ingrid to sleep. Now B part is to write down the time when Ingrid's body temperature is at maximum and minimum. From the graph it is clear that her body temperature is maximum at 12 p.m. and minimum at 12 a.m. which is also same as 24 hours after midnight. So maximum body temperature is shown at 12 p.m. and minimum body temperature is shown at 12 a.m. Now for C part, it is given that during the day, Ingrid's body temperature B can be modeled using this equation. B is equal to minus 0.5 cos pi by 12 t plus 36.5, where t is the time in hours after 12 a.m. Angles are in radians. Write down the amplitude and period. So comparing this equation with the standard equation, we know that if y is equal to a cos bx plus d, a is the amplitude. So in the place of amplitude we have 0.5 because amplitude is modulus of this value. So negative value is not considered. Amplitude is just half or 0.5 and period is given by the equation 2 pi by b. Now b is the value which we multiply the variable with. Here the variable is t. B will be pi by 12. So 2 pi by b is 2 pi by 12. Pi and pi will get cancelled. This is 24. So period is 24. Now for D part, we have to determine the values of maximum and minimum temperature. So the maximum and minimum temperatures are found using with the help of D. Okay, so D acts like the principal axis. The equation of the principal axis is given by y is equal to D. So the curve actually vibrates along this line, y is equal to 36.5. So maximum value can be obtained by adding amplitude and minimum value can be obtained by subtracting the amplitude. So maximum value will be 36.5 plus 0.5, which is the amplitude. Then this gives maximum value as 37 degrees Celsius and minimum value is 36.5 minus 0.5, which will give us 36 degrees Celsius. So maximum temperature is 37 degrees Celsius and minimum temperature is 36 degrees Celsius. Now for E part, calculate Ingrid's body temperature at 7:15 a.m. to the nearest 1 decimal place. So we have to substitute the time into the given equation for her body temperature B. But 7:15 a.m. is the time, so we have to convert it because T is the time in hours after 12 a.m. So if you convert this to hours, T will be 7.25 because it's 7 hours and 15 minutes. 15 minutes when converted to hours, it will be 0.25 hours. So altogether T will be 7.25 hours after midnight. So B will be negative 0.5 cos pi by 12 into T will be 7.25 plus 36.5. Now pi is same as 180. You can convert it to degree. So 180 by 12 is 15. So negative 0.5 cos 15 into 7.25 plus 36.5. Putting this in calculator, the value for B, body temperature, is 36.6607 degrees Celsius. When rounded off to one decimal place, it is 36.7 degrees Celsius. Now F, for that we have to read this part. Raise body temperature is 0.25 degrees Celsius higher than Ingrid's. The graph below shows two cosine curves modeling the body temperature for Ingrid and Ray. Write down the equation modeling Ray's body temperature. So Ray's body temperature is just 0.25 higher than Ingrid. So if you try to write that value, it's going to be negative 0.5 cos pi by 12t plus Ingrid's body temperature was initially at 36.5 and this plus 0.25, which will be 36.75. So this will be the equation modeling Ray's body temperature. Now for the last part, G part, they're asking us to calculate the first time when Ray's body temperature will reach 36.5 degrees Celsius. So we'll equate the equation modeling Ray's body temperature, which we found in part F, to 36.5, because we have to find the first time when Ray's body temperature will reach 36.5 degrees Celsius. So negative 0.5 cos, this is not required, cos pi by 12t plus 36.75 is equal to 36.5. So taking 36.75 to the right side, we will get minus 0.5 cos pi by 12t will be negative 0.25. Now taking negative 0.5 here, dividing minus 0.25 by minus 0.5, we'll get half. So cos pi by 12t is half, or pi by 12t will be cos inverse of half, which will be pi by 3 in radians. So T will be 4. That means T is equal to 4 am. The time when Ray's body temperature will reach 36.5 degrees Celsius will be 4 am. Now we are doing question number 7. In this question, you will predict the reaction times of sprinters based on previously acquired data and their sleeping pattern. Sprinters competing in a 100-meter race should ensure they are well rested before competitions. Studies have shown that a good sleeping habit can improve reaction time. The start of the race is one of the most important factors for an overall fast time. Sprinters need to react as quickly as possible to start signal. In this question, you will explore the reaction times of sprinters with different sleeping habits and how this affects their probability of winning a race. So, there are 20 sprinters and their reaction time is also given here in this table. Write down the mode and median of the reaction time. Now we know that mode is the maximum repeated value. So we can see that here 6 resembles 0.78. That means 6 sprinters. Maximum number of sprinters is 6 in this table. And the reaction time taken by the maximum number of sprinters is 0.78. So mode will be 0.78. Now median is the middle value when arranged in ascending order. So we know that middle value of this 20 sprinters means 20 plus 1 by 2, 21 by 2, which is 10.5. So 10.5th element is the middle value. So first 4 sprinters have the reaction time as 0.75. Next 3 sprinters have the reaction time as 0.76. So total 7 sprinters are done. So 8th sprinter will have the reaction time of 0.77. 9th sprinter will also have the same reaction time. 10th sprinter will also have, and 11th sprinter will also have the same reaction time. So the median value will be actually 0.77 because the 10.5 means 10th element plus 11th element by 2. And 10th element is also 0.77. 11th one is also 0.77. Both the sprinters take 0.77 seconds as the reaction time. So the average of that is again 0.77. So median value is 0.77. Now show that the mean reaction time is 0.77 seconds for this group of sprinters. So we know that mean is sum of the data by number of data. Sum of the data means 0.75 is the data which is repeated 4 times. So 0.75 into 4. plus 0.76 into 3 plus 0.77 into 5 plus 0.78 into 6 plus 0.79 into 1 plus 0.80 into 1 divided by the number of data, which is 20 sprinters we have. So it's 4 plus 3 plus 5 plus 6 plus 1 plus 1, which is 20. So we just multiply these values and then add them. We'll get 15.4 by 20, which is 0.77 seconds. So the mean value is 0.77 seconds. Now, groups of sprinters with different sleeping habits take the same test. The graph below shows the mean reaction time of each group. We have to draw a line of best fit. Actually, these are the points. Let's draw a line of best fit, which should pass through maximum number of points, and there should be approximately equal number of points above and below the line. So this green line would act as a line of best fit for the given data set. Now use your line of best fit and write down the values for R when H is 4 and when H is 7.5. So when H is 4 hours, from the line of best fit we can see that the value of R will be 1.12, and when H is 7.5, which is here, using the line of best fit, the value of R will be 0.9 seconds. Now for question 7e, W is given as 24 into 100 to the power of minus R, where W is the probability of winning a race and R is the mean reaction time in seconds. Calculate the value of W when R is 0.77 seconds. Give your answer correct to two significant figures. So using the formula W is equal to 24 into 100 to the power minus R, the value of R is given as 0.77. So substituting it into the formula, we'll get W is equal to 24 into 100 to the power negative 0.77, which is equal to 0.69216756 using a calculator, which is approximately 0.69, correct to two significant figures. So this is the probability of winning when R is 0.77 seconds. Now 7F. Explore the probability of winning a race for sprinters with different sleeping habits. In your answer, you must include or identify the two relevant factors affecting the probability of winning. Calculate the probability of winning for sprinters with different sleeping habits. Comment on the relationship between the probability of winning and sleeping habits. Justify the accuracy of your findings. So we already have this table. We have to fill the table. The H values are given as 4, 7.5, 8, and one random value we can take, which I took as 10. The R value, which we have already found here, when H is 4, R is 1.12, and when H is 7.5, R is 0.9. So we are substituting that. Also for 8, they have given it as 0.77, and for 10 it is 0.73. Using the line of best fit, we can find when H is 10, it is approximately 0.73, the R value. So now W is equal to 0.14. Using the formula here, we'll substitute R as 1.12, we'll get W as 0.14. When you substitute R as 0.9 here, we'll get W as 0.38. And when we substitute R as 0.77, we'll get 0.69 as W. And when we substitute R as 0.73, W will be 0.83. So from this formula, we can identify that the probability of winning basically depends on the reaction time as well as the sleeping hours. Also, it depends on other factors such as talent, training, experience of the sprinter, etc. And we have already completed the table, and also we can see that there's a positive relationship between the probability of winning and sleeping habits, because as the sleeping time increases, the probability of winning also increases. The findings are inaccurate with good justifications, as the line of best fit is an approximation which varies from person to person. Therefore, the relationship between the reaction time and sleeping time cannot be linear. Question 8a. Write down the missing values in the table. So we have here the stage values 1, 2, 3, 4 and so on. And on the second column, we have vertical length of the rhombus V, 4, 16, 36, 64, and we have to fill the rest. So here if we see clearly, we can see that these are square of even numbers. This is 2 square, this is 4 square is 16. Then next even number is 6, 6 square is 36. Next even number is 8, 8 square is 64. So the next even number is 10 and 10 square is 100. And next even number is 12 and 12 square is 144. So we can fill the missing values as 100 and 144. Describe in words two patterns for V. This is question 8b. So here, as discussed earlier, square of even numbers starting with 2 till 12 we can say, or we can also say that these are even square numbers from 4 to 144. Now 8c is to write a general rule for V in terms of n. So if we see the pattern here, 4, 16, 36, 64, 100, 144, etc. The values of n also, if you try to compare, this is 2 into 1 the whole square. This is 2 times 2 the whole square. This is 2 times 3 the whole square. This is 2 times 4 the whole square. This is 2 times 5 the whole square. This is 2 times 6 the whole square, and so on. So if you see the pattern here, the nth term will be 2 times n the whole square, or 2n the whole square, which is 4n square. Also n belongs to integer values, basically positive integers, where 0 is excluded, and n is less than or equal to 6. Verify a general rule for V. So for verifying, we are taking the formula V is equal to 2n the whole square and substituting n as 7. So when n is 7, V is equal to 2 into 7 the whole square, which is 14 square, and which is 196. So when n is 7, it's going to be 196. Now for E part, we have to investigate the values in the table to find a relationship for the area A of the rhombus in terms of n. And we have to predict more values and use all these description to satisfy our answer. So we already know the value when n is 5, it's 100, 144. And if the pattern continues, we know that for n is equal to 7, it's 196. We found that. And horizontal length is the second column. If you see here clearly, these are all even numbers, 2, 4, 6, 8, 10, 12, 14. So it will continue. The area of the rhombus is first it's given as 4, then 32, then 108, then 256. So if it continues, we can see that these are nothing but 4 into the cube of the stage. That means this is 4 into 1 cube, which is 4. Then next one is 4 into 2 cube, which is 4 into 8, which is 32. Then it's 4 into 3 cube, which is 4 into 27, which is 108. Then it's 4 into 4 cube, which is 4 into 64, which is 256. The next one will be 4 into 5 cube, which is 4 into 125, which is 500. Then it's 4 into 6 cube, 4 into 216, which is 864. And last one will be 4 into 7 cube, which is 4 into 343, which is 1372. So we have to describe in words a pattern for A. So we can say that A is fourth multiple of cube numbers. Then we have to determine the nth term or general rule, which we can simply say as 4 into n cube, where n belongs to C, or else we also know how to find the nth term for a cubic sequence. So we have to write the terms. So we wrote the terms 4, 32, 108, 256, 500, 864, and so on. And we are finding the difference between them. 4 plus 28 is 32. 32 plus 76 is 108. 108 plus 148 is 256. 256 plus 244 is 500. 500 plus 364 is 864, and so on. And again, since the difference is not constant, we'll again continue to find the difference again. So 28 plus 48 is 76. 76 plus 72 is 148. 148 plus 96 is 244. 244 plus 120 is 364. So here the second difference is also not constant. So we'll again find the difference. 48 plus 24 is 72. 72 plus 24 is 96. 96 plus 24 is 120. So the third difference is constant. From this we can see that this is a cubic sequence. And for cubic sequence, we know how to write the pattern. 6a will be the third difference. 12a plus 2b will be the second difference, 7a plus 3b plus c will be the first difference, and a plus b plus c plus d will be the first term of the sequence, where a, b, c, d are real numbers obtained when we write the nth term of a sequence. That means nth term of cubic sequence can be written as an cube plus bn square plus cn plus d, where a, b, c, d are real numbers which are found using this pattern. So we start solving from the bottom part. 6a is 24, so a is 4. Then substituting a here, 12a plus 2b is 48. So 12 into 4, which is 48 plus 2b is equal to 48, or b is 0. Then 7a plus 3b plus c is equal to 28. Substituting a as 4 and b as 0, we get c also as 0. Then finally a plus b plus c plus d is 4. Substituting a, b, c and finding the value for d, we get d also as 0. So substituting a, b, c, d in the nth term formula, we get that nth term of this cubic sequence is 4n cube. So general rule is 4n cube. Now we have to test for the general rule. So you have to take any values starting from 1 to 4. So let's take n is equal to 3. So the value of a will be 4 into 3 cube, which is 4 into 27, which is 108. And that is the answer here. So it's correct. Then we'll move on to verification, because next we have to verify. So to verify, we'll take the values greater than or equal to 7. So when n is 7, a is equal to 4 into 7 cube, which is 1372, which is the value obtained here. So we have verified it. Now we have to finally justify the general rule. To justify the general rule, we already know that the area of a rhombus is half into product of the diagonals, which is same as half into the vertical height into the horizontal height. And we know the pattern for V is 2n square and pattern for H is 2n, because H is all even numbers. We know that the pattern for even number is 2 times n, 2n. And for V, we have already found the pattern as 2n the whole square. So A is half into 2n the whole square into 2n, which is 4n square into 2n by 2. 2 will get cancelled, it's 4n cube. So we justify that the pattern which we found earlier, the general rule which we found here, 4n cube, is same. Yes, so that's the end of the paper. Thank you.